Everybody. So in this video, we're going to be presenting this week's news related to the vagus nerve, and we're going to be covering what the latest developments are. The good thing about the world of the vagus is that there's a ton of people researching this field and publishing stuff basically every week. And good news for us, we are just now out of the summer season. So those researchers, those academics, let's give them a big round of applause. Let's all pat ourselves on the back. They have been taking an incredible summer vacation. And so I expect over the next month to 3 months, as they start getting back into their labs, start publishing, that the influx of vagus nerve related research is going to become substantial. So our Friday calls will more likely than not be a kind of a weekly review of just the latest news. And I think the best way to understand the vagus is to really be apprised of what the research shows. You'll notice that in my Facebook group, if you're not in it already, please join, is that we often cover the latest news, the breaking stories. You know, this is like Sterling's News Hour. We're covering stuff here. So let's get started with the first one. This is actually a cool continuation of a bit of research that happened over the last week. And let me see if I can pull that up too. So there's a really good amount of research on, how would I call it? The connection between the vagus nerve and the stomach. There was a recent published article. Sorry, let me end that. A recent published article that talks about how if you stimulate the vagus nerve, you increase the synchronicity between the brain, the vagus, and the stomach, and how that's really a very, very important aspect of generally of health. So let's see here. Just want to get that up here real quick. I have like just so many cool articles. Some of you guys will have, you will have seen that posted like a ton over this last week. So let me see. Where is it? So yeah, the first article we're going to be focusing on here, and then I'll get the supporting one up, is that the vagus nerve mediates the stomach-brain coherence, area. So this is one of the things. I've always really made a point to say it's not just the gut-brain axis. The axis part refers to the vagus nerve. So if your vagus nerve is dysfunctional, there is no gut-brain axis. There's no amount of supplements or pills or probiotics that you can suck down or spend $800 a month on that are going to repair the vagus nerve if you have an impaired vagus nerve. You have to fix the axis part too for the gut-brain part to work. And then you also have to work on the brain part. And so here on this video today, we're going to cover in a separate section, after I'm done presenting the latest news, is on the brain function as it relates to kickstarting your vagus nerve. So we're going to do some reviews. So if you were part of our video last week on memory, we're going to continue that and continue the testing. So this is just published on the 13th of September, so just about 3 days ago from the time of this. But the vagus nerve mediates the stomach-brain coherence. So what this says is that interactions between the brain and the stomach shape both cognitive and digestive functions. Recent human studies report spontaneous synchronization between brain activity and gastric slow waves in the resting state. However, this finding has not been replicated in any animal models, which is funny. They're saying that it's human studies have reported the spontaneous synchronization between brain activity and gastric slow waves, but they wanted to replicate that in animals. The kind of stuff we're doing in vagus nerve work is that they're starting in humans first and then saying, hey, we need to make sure we study this in mouse and rats next. So it's actually a real big difference from when I started this, about a decade ago going into research, was that they would always start with a mouse model or a rat model. Now they're just going right in humans because it's safe, and then they're doing back reversal stuff. So the neural pathways underlying this apparent stomach-brain synchrony is also unclear. Here, we performed functional magnetic resonance imaging, so they used an fMRI, while simultaneously recording body surface gastric slow waves from anesthetized rats in the fasted, meaning not eating, and then postprandial conditions, and performed a bilateral cervical vagotomy. So they cut the vagus nerve of these rats, both sides, the left and the right, to assess the role of the vagus nerve. That's how you do it. If you want the best research on understanding the vagus nerve, you cut the vagus nerve and then you find out what happens. So continuing, the coherence between brain fMRI signals and gastric slow waves was found in a distributed gastric network when the vagus nerve was working, including subcortical and cortical regions in the sensory, motor, and limbic system. So the vagus nerve connects to your brain, your limbic system. So if you're buying courses that talk about limbic retraining, you can't retrain your limbic system. You have to retrain your vagus nerve and your cortical cortex. The stomach-brain coherence was largely reduced by the bilateral vagotomy and was different between the fasted and fed states. These findings suggest that the vagus nerve mediates the spontaneous coherence between brain activity and gastric slow waves. 1 second. What is this? Ellensburg. Okay. Sorry, getting a call from someone. So these findings suggest that the vagus nerve mediates the spontaneous coherence between brain activity and gastric slow waves, which is how you digest food, which is likely a signature of real-time stomach-brain interactions. However, its functional significance remains to be established. Now, I can just tell you, the functional significance is that if your vagus nerve doesn't work, you don't digest food properly. You have symptoms like gastroparesis or dysmotility or reflux, these kinds of things. So if you kickstart the vagus nerve, you actually have food moving through your body, not sitting there and digesting and having bacterial overgrowth. So you could see potentially that stimulating your vagus nerve could be used as a treatment for a number of different problems. So anyway, that is this this study. I'll put that in the chat. Awesome. Good to see y'all here. So that's that one. Then there's another one that's interesting, which is the association. So in neuroscience news, dozens of gut bacteria associated with multiple sclerosis, right? So this is a vagus nerve issue thing because we often talk about the gut-brain axis and the gut microbiome. So researchers reveal significant differences in gut bacteria patients with multiple sclerosis compared to those without the autoimmune disease. The study also uncovered novel mechanisms by which the bacteria may influence the disease. An international research consortium at UC San Francisco has shown significant differences between the gut bacteria profiles of multiple sclerosis patients and healthy individuals, as well as between MS patients receiving different drug treatments. While some of these changes had been reported before, most are reported for the very first time. The group also uncovered novel mechanisms by which these bacteria may potentially influence disease development and treatment response. Okay? So let's scroll down a little bit and see if we can find some things. So the findings could lead to new therapeutics that involve either manipulating the microbiome or dietary interventions. Now, what I can tell you from my own experience is that by treating the vagus nerve specifically in cases of MS, you can ameliorate a lot of the symptomology of MS because MS is an autoimmune condition. So vagus nerve stimulation is absolutely an indicated treatment for MS. And so the way that they're doing this is by introducing gut bacteria or new bacteria species and testing what's in there versus what was not. They say, we were surprised by the number of species that were differentially present in MS when compared to controls, right? So that's very interesting. The study was the second in a series being conducted by the MS organization. The first study validated the household control protocol, showing that it increases statistical power in population. Yeah, so answering the second question requires mechanistic studies with individual bacteria to understand their metabolic profiles. Still, the researchers got some hints at what the bacteria they found are doing by studying the potential pathways that these bacteria encode, right? So that's very interesting. Now, let's see as well. So one other thing is short-chain fatty acids are known for their anti-inflammatory properties. So this suggests that interferon works by increasing the transportation of these molecules from the gut to the bloodstream, and then most likely from the gut up into the brain through the vagus nerve, okay? An unhealthy vagus nerve does not know how to differentiate between good or bad transport. So if you have a dysfunctional vagus nerve, it will then propagate bad chemicals up into your brain stem. Another reason why having a healthy vagus nerve is not just something that you should be doing or focusing on once you've gotten sick. If you have friends or family who you think are high risk cases for some of these things, you should get them on the Vagus Cure protocol. You should get them doing some form of vagus nerve stimulation right now. And there's lots of ways you can do it. But a system, look, There's a reason why the Facebook group has grown to 20,000 people. Fact. There's a reason why so many people are signing up for our programs. Fact. There's a reason why a daily system of stimulating your vagus nerve in some way, shape, or form is a really, really, really good idea. If you want a really, really simple way to stimulate your vagus nerve, our program offers the most effective, simplest, straightforward way to go about doing that. If you want to schedule a 10-minute call, we have that. We have spots available. You can speak to one of our team members, and you can learn more about what our program entails. But yeah, just want to close that one up. So gut bacteria, vagal nerve function is associated with the onset and progression and severity of MS. Very interesting. Boom. Okay, so next one. So let's talk about hypothyroidism and hyperthyroidism. So we looked at the thyroid, and I've always sort of believed that that thyroid was sort of a secondary thing or like a different thing from the vagus nerve. But I always found people at a certain age would start to encounter thyroid issues corollary with stomach issues, with digestion issues, with weight gain, with fatigue, with the inability to sleep. But those are symptoms of vagus nerve dysfunction. So what we found actually is that vagus nerve dysfunction comes before dysfunctions of the thyroid. So if you keep your vagus nerve healthy, you actually may not ever have to go on a thyroid medication. And if you are on a thyroid medication, you can continue to take a thyroid medication, and that may work for some time. I think people at a certain age just generally are on thyroid medications forever. But wouldn't it be nice to be able to not have to be on a thyroid medication forever? The way you would do it, allegedly, is that you would work on the vagus nerve. So here's the research. So a great deal of uncertainty persists regarding the exact nature of the interaction between the autonomic nervous system, vagus nerve, sympathetic, and thyroid hormones in the control of heart rate. In the present work, we investigated whether reduced vagal influence could contribute to tachycardia in hyperthyroidism, meaning overactivity in the thyroid. Vagal excitability was studied in 10 hyperthyroid patients. Prolongation of RR interval, which is an HRV measurement, in response to carotid baroreceptor stimulation by neck suction. That could be an interesting stimulation, guys. Type a 2 in the chat if you would be interested in me doing a video on stimulation of the vagus nerve with neck suction. Neck suction. I'm interested in that. I'm going to put a 2. Frickin' A, I'm going to put a 2 in the chat for that. Okay? Who's interested in vagal suction to induce changes in their vagus nerve? I'm absolutely down for that, okay? So anyway, they changed and they increased the vagus nerve activity by sucking on the vagus nerve in the neck. And by doing that, it was found to be less in the hyperthyroid state compared to the control state after therapy. So if you did neck suction, you increased vagal nerve activity, and it found that people were less in the hyperthyroid state. Damn. So vagus nerve activation is a treatment for hyperthyroid. The extent of nocturnal bradycardia, meaning the slowing of the heart rate, and the vagal excitatory response to the central effect of low-dose atropine, which basically does work on the vagus nerve, was significantly reduced in hyperthyroid patients compared to euthyroid controls. We concluded that in the hyperthyroid state, cardiac vagal motoneurons were in low excitability state. So we concluded that the hyperthyroid state was a result of decreased vagal nerve activity. Okay? We speculated that the inhibition might have resulted from thyroid hormone action on CNS structures, integrating autonomic function and behavior. Very interesting. Okay, so I'm going to share that in the chat. Damn. Yeah, interested in learning anything vagus? Yeah, definitely. And tell your friends, every one of you watching probably knows someone who's on thyroid medication, right? So if it comes up, be like, hey, another opportunity to introduce the vagus nerve in conversation. As if we needed one other inlay to say, Vegas, Vegas, Vegas. Anyway, So next one, which is from 2020. So this is actually really new. This is from the Journal of Research in Clinical Medicine. And this is really interesting. So vagosympathetic imbalance induced thyroiditis following subarachnoid hemorrhage, a preliminary study. Okay? This is really, really interesting. So in an ischemia-induced vagosympathetic imbalance following a hemorrhage for the onset of autoimmune thyroiditis. So they induced thyroid disorder by intentionally damaging the vagus nerve in the heart. So thyroid hormone levels were measured weekly and animals were decapitated. Thyroid glands, vagus nerve ganglia, and parts of the vagus nerve inside of the skull were obtained from tissue archives, were re-examined with routine immunohistochemical methods. Thyroid hormone levels, hormone-filled total follicle volumes, TFVs, per cubic millimeter, degenerated neuron density of vagal nuclei, and neuron density of superior cervical ganglia were measured and statistically compared. The mean neuron density of superior cervical ganglia was estimated at 8,000 in the study group animals with severe thyroiditis, okay? So the neural density of vagal nerve ganglia was around 8,000, 7,000 in the whatever sham group, and 6,000 in animals with normal thyroid glands. So in control group, T3 was 107, while the mean was 43% and the nuclei was 3. In the sham group, T3 was 96. Okay, so this caused elevated TSH. This is why I get why it's hard to read these research papers, because they just jam this stuff up. In the study group, T3 was 54. So in damaged vagal nerves, TSH levels were very, very low. And the vagal nuclei was 42. So sympathovagal imbalance characterized by relative sympathetic hyperactivity based on vagal insufficiency should be considered as a new causative agent for hypothyroidism. Huge right there. Boom. This is like a knockdown, beat down argument on if you have a thyroid issue, is that leading to if you have a thyroid issue, it means you have a vagus nerve issue. And so I'm comparing these two. This is the facts. There are two forms of manifestation of vagus nerve dysfunction. If you have reduced vagal activity, you can get hyperthyroidism. And if you have too much sympathetic and too little vagal nerve activity, vagal insufficiency, it should be considered as a new causative agent for hypothyroidism. You get it? So this answers the age-old question of, should I stimulate my vagus nerve or not? Yes, you should. You should just stimulate your vagus nerve, folks. At this point in time, you should just be stimulating the vagus nerve. By analysis, they found that too little vagus nerve activity will result in either hyperthyroidism or hypothyroidism. It goes both ways. How that manifests is based on basically, are you a highly stressed person or a less stressed person, right? If you're too stressed, you'll be hypothyroid. And if you have too little stress but a damaged vagus nerve, you'll have hyperthyroidism, okay? So that means if you have no vagus nerve, you're going to be screwed either way. If you have a vagus nerve, at least you're going to be in an optimal state. You need a vagus nerve to balance a sympathetic overdrive state, okay? So anyway, just want to conclude there, right, with this first aspect of the videos. I'm going to start cutting these up so there's not, a 1 hour long thing you have to tread through. So this is the thyroid conditions are a direct result of vagus nerve dysfunction. Okay, that is the title of this first little talk. So anyway, just want to thank everybody for watching us here on YouTube. Make sure you subscribe and like, and I'll see you in the next one. Bye-bye.